So today I'm going to do what many people have already done and suggested I do for the past 8 years, and that is remove my EZL and replace the heatsink compound on the rear side. That's what an EZL looks like. If you're not familiar, that is the ignition control unit on a KE Jetronic car. This is the advanced version that also does knock sensing and individual cylinder timing, identified by the additional connector for the knock sensors and having 8 pins on each of these connectors instead of just 4. This is a dead one, this is for my research only, but on the rear side is where the heatsink is applied from the factory, and they also have a thermally conductive foil that goes over the top of that, which is basically to increase the efficiency of the heat transfer. It is not an electrical insulator because this body is actually grounded, and of course having the nuts on here just electrically connects that to the body anyway, so it's absolutely not an electrical insulator. It is simply thermally conductive, and I believe somewhat protects that factory heatsink compound from water ingress and being washed out. You can't buy that sheet anymore. I mean, you can probably just cut it out. It is standard film that's used in electronics for heatsinks and whatnot, but I don't bother with that. I just apply a new heatsink compound after cleaning all of that old stuff off and then bolt it down. In regards to that film, it's clearly explained here that it is a heat conductive protective foil for improved heat dissipation, and the foil must not be removed. Well, you can't buy them anymore, they've discontinued them, so they can't be that important. Although, yeah, you can't always say that. The reason I printed this off was actually to find out the torque specs for those 3 nuts, but they don't mention it anyway. But a couple of things that I found interesting in here, there's a couple of revisions of the EZL for the 104-980. Initially in 1989, they modified it with a different map and fault memory programming. And then again, later. Couple of revisions anyway, but the most interesting thing of all is in 1991 they introduced one that was modified specifically for being used to the first gear start all the time, and that's on the 124051. So it looks like from standard factory configuration they started with first gear from August 1991, so that's interesting to know. I did not know that. I've got a sedan, so that doesn't apply to me, but I'm sure, in fact I will, modify that at some stage to have the first gear start. It is simply a case of moving the position of one spring. It's not rocket science, it's all in the valve body, and I've got the kit to do it. Anyway, let's get started. So this is where the EZL is found on the vast majority of cars, just hiding underneath the brake lines and the low pressure air conditioning suction line there. First thing we need to do is remove all of the connectors. They simply pull off quite easily. And there's also one vacuum connection. That's all of them removed already. It's really quite simple. And then there's just 3 10mm nuts around the perimeter. The manual did talk about having washers with these nuts, but that's not the case on either of my cars. My nuts applied to these EZLs actually have incorporated washers, so maybe that was a revision at some stage. Or someone has changed the EZL at some stage, but in any case, as long as it holds it down there, that's the main thing. And you can already see that is coming loose now. And out it comes. You can see that factory heatsink compound applied to the rear of the EZL there. And of course that does have that film on there. Now concerningly, you can see an outline of dirt inside the outer perimeter of the EZL, which means it was not making full contact with the body. The same pattern is repeated on the back of the EZL, so definitely that heatsink compound has shrunk in its old age, and it's no longer making contact. Either shrunk or it's been washed out. I then moved on to cleaning that area underneath the EZL to get rid of all of the dirt and have the surface as clean as possible to make the best possible thermal transfer efficiency. You don't want any grime or grains of sand or anything like that, or even the old heatsink compound interfering with that thermal transfer. Obviously I can only do so much while I'm holding the camera at the same time as scrubbing with an old toothbrush, but I will complete this off camera. You can already see what a good job this window cleaner is that I seem to be in love with for cleaning everything. So that's what I ended up with. It's nice and clean. That will dry while I'm cleaning up the EZL. And I just used lint-free science wipes for the purposes of cleaning that surface as well. And here you can see that protective film. It comes off quite easily. I'm not going to reuse that. If you want to, you're more than welcome to, but anytime I've tried to clean that, it just disintegrates. And yeah, I don't see the point of it personally. I'd rather just have an ample amount of heatsink compound in there to fill in the void. So cleaning that off, I just once again used my window cleaner and an old toothbrush. It is very sticky. This takes quite a while to get it all off. You could probably use harsher chemicals, but this is what I had on hand. Just one thing to bear in mind, there is a vent on the top side of that EZL, so don't go crazy with cleaning fluid and spraying it everywhere, because it will get inside the EZL. And the whole purpose of this exercise is to try and extend its life, because these things are getting harder and harder to find. This is no longer something that I can ignore because of the scarcity of these and the ridiculous price. It's one thing to have new everything in my ignition system on both cars to help extend the life of this, but yeah, this is no longer avoidable. So this is the heatsink compound I use. It is just generic garbage that's used for electronics, nothing special. Some people like to use Arctic Silver CPU heatsink compound, but it's kind of a waste of time. This stuff is more than good enough and it does the job. When applying it, there's no need to be too careful with how much you put on there. I like to put a very healthy amount to make sure that there is 100% contact between the back of the EZL and the sheet metal that it's being bolted onto. And I spread that heatsink compound all the way out across that rectangular area that is contacting the body. It's then just a case of bolting it down and making sure by hand that it is evenly tightened up, which is what I did here. You don't want to go too tight because you will snap those studs off. One thing that pleases me is seeing a very small amount of heatsink compound oozing out around the edge there. If it's like that around the whole perimeter, then you know you've applied enough, and it has 100% coverage between the back of the EZL and the body. If you get massive amounts oozing out the edges, well, you've put too much and you're just going to make a mess. So there is a fine balance between how much to put on there. I just do it by feel, and I've pretty much nailed it the first time. One interesting thing about these connectors is they do actually have O-ring seals, and they are standard O-rings if you want to replace them. It does maintain a watertight connection keeping water out of the pin areas and causing corrosion and various electrical issues. So I will change that at some stage, but for the purposes of this video I just left it out. It's then just a case of reconnecting all of the connectors that were removed to take it out, and that's pretty much all there is to it. The job is done. If you want to, go for a test drive. If you really are curious, measure the temperature of your EZL on 2 identical days after an identical drive, and see what the temperature is before and after doing this job, and if it has made any difference whatsoever, I would be interested to know.